All right, we're back at the bench. So this girl did very well. She proved my concept and was able to safely go over, what was it, 134, was it? Really great. This was not a pretty build. This is just a kind of a get her done type of build, just to see if my concept would work. Concept of basically having the center of gravity very far forward in the chassis, in front of the center of pressure. Very long wheelbase, so this thing will never fly unless I check it in at SFO. The thing will never fly, and that's the main purpose of it. You know, I'm kind of cheating with the thrust vectoring, actually pushing the car down a little bit. But she needs to go. It's not going to be good enough to go even close to 200 miles an hour. For one thing, we only have about a quarter mile of acceleration before we lose sight. With a chase car, you might be able to extend it out to a half mile if your chase car is fast enough. But standing on the side of the road, you got about a quarter mile. So acceleration becomes an issue. Nobody really talks about it. This thing is heavy.
You know, you remind me of the Doughboy. If I poke your stomach, we'll make it go, oh!
Really heavy. It's 24 pounds when it's fueled, ready to run. This engine is only good for 27 pounds of thrust. Pretty impressive acceleration compared to a regular car. But when I'm trying to reach, you know, a speed above 220, it's not enough. So this car needs to lose roughly half of its weight. So how do you go about doing that? So that is why we're here. The other problem with this car, it is not aerodynamic at all. She has so much drag, she can read books to children. It's not happening. So this whole concept of, you know, wide chassis, all that air just being disturbed, it's not happy. I can tell that it topped out at, you know, at around 130, and that little engine could not push it through the air any faster. The other thing, she's ugly. Like I said, this was a proof of concept, get it done quickly, and to see if I can, you know, beat the record of, what was it, 94 miles per hour. That happened pretty easily. My third run, it was beaten. So now we need to improve it. You know, we're gonna retire this one, and we're gonna build a new one. So if you had a task to build a high-speed car, a speed run RC car, what would you build? Seems like there's only two choices. We have either Aarma or Hobao. So which one do you choose? Aarma, Hobao, Aarma, Hobao? Well, I went a different way. I'm going with this. That's right. I'm going with Traxxas. Of all the brands, you would not think of Traxxas as your go-to for speed running, but I have a theory, and that's what this project's going to be. Is just kind of going through the theory. We're going to dive into the chassis development, the suspension, aerodynamics. We're going to use every tool that I have in my shop, 3D printing, to try to make the new car work a lot better than this. The goal is to be half the weight, a lot more aerodynamic. And we'll see how it goes. Wish me luck.
What the fuck is this piece of shit?
Okay, so why did I choose the Revo? For three main reasons. Let's go over them real quick. So obviously all the driveline is going to be wiped away. It's not going to be used, unfortunately. This includes the engine, the gearbox, even the prop shafts, differentials. None of it is going to be used. What I do want to use is the suspension, mainly for the lay down Formula style shocks. So they're inboard and they're laying down. Nice way to get it out of the airstream. So the only thing that's in the Airstream is this connecting rod here, and of course the A-arms. Another reason why I like the big diameter tires, along with the long travel suspension. So my runway is, the runway I go to is nice and straight and long and safe to operate in, but it's rather bumpy. So I need the suspension. I'm not going to fall into the trap where I need to keep it as low as possible for better aerodynamics. Low does not necessarily mean better, especially in a bumpy environment where you can, get a chassis strike and really launch the car up. I'm not going to have that issue, hopefully, because my suspension will hopefully absorb all of the bumps. As you saw in my previous video, there are a lot. So I need the suspension. And I think I can achieve good suspension travel, and still be aerodynamic and lightweight. All right, quick note about the wheels, or the tires, I should say. I like the diameter of these. These are just over 6 inches in diameter. I'm not gonna be running these. These are good for maybe 60 miles an hour before they blow up. Not nearly good enough for what we're doing. I'm gonna have to build custom wheels and tires. So that's gonna be one of the products of this. And the reason why is basically RPM. The larger the diameter, the slower the RPM that is necessary to achieve the speed that you want. So in this case, let's see, we had, so 165 millimeter at 250 miles an hour is 13,000 RPM. 110 millimeter, which is the current, foamy tire, that needs to spin at 19,500 RPM to reach 250 miles an hour. But that's not the only thing. I know they're spinning those tires faster than that to achieve the speed of over 200 miles an hour. So you might have a car speed of 220, 225, what the current record is, but I'm sure his wheel speed was closer to 250, 260 to get that car up to speed. So just a quick note on the tires, wheels. You'll see it, what I do, and it's not gonna be at the home shop. It's gonna be at the machine shop, because that's what's necessary. Anyway, take care.